know, we don't do the unit circle for nothing. We use it in conjunction with our trig identities. Okay? All the trig identities will be given to you on the IB test, I believe. They'll be on your formula sheet. But they're on this formula sheet. This is not the IB formula sheet, but they're all on this formula sheet as well. Okay? The fundamental trig identities, those should be pretty familiar to you. For example, sine squared plus cosine squared equals 1. Yeah, it's 1. That's like the trig Bible right there. Every trig identity can be reduced back down to sine squared plus cosine squared equals 1. But the ones that we're going to focus on today is going to be the sum and difference identities. Those are fun. Those are fun. Yay? Okay, so if you take a look at it, you don't have to rewrite the identities. They're given to you, right? You just have to know which one to use it. All right, let's see if there's a pattern, shall we? If it's the sign of addition or subtraction, the pattern goes sine, cosine, cosine, sine. Repeat after me. Sine, cosine, cosine, sine.
Sine, cosine, cosine, sine.
Very good. And then cosine goes cosine, cosine, sine, sine. Absolutely, right. It's cosine, cosine, sine, sine. So here's what's happening. You're adding, subtracting two different angles, and then you're going to use the sine and the cosines. Now, the sine and the cosines will probably be from something from the unit circle, so that way it's easy to calculate. All of this should be calculatable without a calculator. Yay? All right. Another pattern. Another pattern. If it's sine, the sign stays the same. Right? If it's cosine, it's the opposite. So if it's cosine of a minus, it's a minus, it's a plus in between. Yay? Okay. All right. So, I mean, you know, it's in front of you, but it's pretty easy to memorize. So, here's how this works, right? The cosine of 15 degrees is not on your unit circle. It is not. But you can manipulate the problems on your unit circles to get to 15. How do you get 15? 45 minus 30. So, would you not agree that the cosine of 15 is the same as cosine of 45 minus 30? Right? Okay? Okay. You could have picked other ones, right? 135 minus whatever. Could also be 50 degrees. But you always pick stuff that you know that's on the unit circle. So, you know it's cosine, so go cosine, cosine. Hey, there you go. Cosine of 45, 45, 30. Those are all being multiplied by the next to each other. Multiplication. I'm going. Here we go. Since it's a minus, then it's going to have a plus. Sweet. And then go sine, sine. So sine 45, sine 30. Okay? And these are easy. Cosine of 45. For 2 over 2. Cosine of 30 is over here, so it's. Can you believe it? Right? Oh, it doesn't seem hard for it. No. Alright. And then sine of 45. 2 over 2, sine at 30. Yeah. Yeah. Yay! Thank you. There we go. Multiplying it out, this is the square root of 6 over 4, plus the square root of 2 over 4. So it's the square root of 8 over 4. No. False, right? You cannot add inside radicals, silly. Such an algebra 2 mistake thing to do. All right. You can, though, combine it into one fraction since they have a common denominator of 4. It's just square root of 6 plus the square root of 2. Ta-da! That is the exact value of cosine 15. Notice by exact value, I don't want any decimals. Because if you stick in your calculator, you can get decimals. If you have decimals, you can have rounding error, and that's not the exact value. Yay? Yay. Okay. Here we go. What? Cosine at 75. Here's the second example. Talk to me. Oh, you want to use 45 and 30 again? Fine. Here we go. Sure. Well, this is true. This is true. I like 45 and 30. They are very friendly angles. Here we go. 45 plus 30 is how you get to 75. Right? It's still cosine, so cosine, cosine. I love it. I love it. Here we go. So I got cosine 45, cosine 30. Since it's a sum, the original one is going to be this. Alright. Sine 45, sine 30. Yay? Yay. Okay. It's the same stuff as before, just a minus this time. So can we agree that this is going to be square root of 6 over 2? Is that right? That's what it was last time, right? 4 over 2. 3 over 4. And, oh. Alright. Here we go. So square root of 6 over 4 minus the square root of 2 over 4. Right? So the only difference from last time is the minus. It's still square root of 6, square root of 2 all over 4. Yeah.
You're losing me after you figure out those.
Yes, sir. Let's go back. I'm sorry. I was trying to. Nope. I was trying to skip a couple of steps. Hang on. All right. Start over. Cosine 45. Listen.
Line up.
Do you have your unit circle up there? The yellow thing. You didn't get one!
Oh no, I have one.
Oh, you have one. That's good. Cosine 45.
Where is it? Oh, wait.
Yeah.
Okay, cosine is x, right? So square root of 2.
Amen. Root 2 over 2. Okay, look ahead. I need cosine of 30.
Square root of 3 over 2.
Yeah. That's where I got the root 6 over 4. Just multiplying it together.
Okay.
True? Alright, excellent. Sine at 45.
Square root of 2 over 2.
Yeah. And then sine at 30
is that 1? 1 over 2?
half. Yeah, that's half. Yay? So that would be square root of 2 over 4. Right? So same as last time, it's just a minus in the middle. So combining it into one fraction, 6 minus root 2 all over 4 is the exact answer.
Okay.
Yay? Yeah. Let me know if I'm skipping over something. Let me know. Good. Oh man, we're at the last problem of the day. Oh. Okay. I know. You're gonna practice this like a puppy. Some of you are gonna have some fun proving it too. What? Okay. Here we go. Yeah. There's no over 12. Okay. Yeah. Right. Okay. Here's how you think of it. That's right. There's no over 12 on there, but we do have an over 6, an over 3, and an over 4, which are all multiples of 12. So, you want to find a combination that will reduce down to a 6, a 3, or a 4. Think. Let's get to 7. What adds up to 7?
3 and 4.
3 and 4. And don't 3 and 4 go into 12? Right. Okay. So here we go. Could you say that, let's do some work up here, 7 pi over 12 is the same thing as 3 pi over 12 plus 4 pi over 12. True? Which reduce down to, yeah, which are all on the unit circle. Right. Yes. So we're just looking for the sine of pi over 4 plus pi over 3. And sine goes sine, cosine. Yeah. All right, that's what. Here we go. So sine pi over 4 Cosine. Hello. Nope. Okay. Here we go. There it is. Yeah, let's try that again. There we go. Got it. Got it. Sine pi over 4 cosine pi over 3. Since it's plus, we keep the sign. Thinking that here we go. Sine, cosine, cosine, sine. And notice the order. It goes pi over 4, pi over 3, pi over 4, pi. A, B, A, B. Woo! Yes! Yes! Here we go! All right. The sine at pi over 4, aka. Oh. Yeah. So this doesn't get very creative. You're going to see a lot of those there. Cosine pi over 360. Square root of 3. I need you. Nope. Here we go. I think it's tired of me. Here we go. 1/2? Yeah. Plus root 2 over 2. And? Yes.
I have no way.
No. Because of addition? It's fine until you get to subtraction. Alright. Square root of 2 over 4 plus square root of 6 over 4. Man, that thing comes up a lot. Square root of 2 plus square root of 6 all over 4. Okay. How many of you have your books with you today? It was not on the syllabus, boogers. All right, so here's what we're going to do. On your syllabus, we're going to switch this around, okay, because I didn't have the classwork on the syllabus. I am sorry. So we're going to switch this around, right? On the syllabus, let's take a look at this. Hello?
Did you turn the list off?
There it is. All right. On the syllabus, you had a worksheet for homework, right? You had a worksheet for homework, but then the classwork wasn't on there. So swap. You're going to do the classwork as the worksheet, and then the homework will be the book problems. Yay? So write this down on your syllabus. Page 425 to 426, I think it goes to. It's going to be numbers 3 to 42 by 3s. Yay? And since I will be gone on Friday, right? Since I'll be gone on Friday, just turn everything into me on Tuesday. Okie dokes? Okie dokes. All right. If you have your book with you, this is definitely the longer one, so I'll get that out of the way. The worksheet only has 7 questions on it. Yes, sir. You don't have textbooks? I gotta get you textbooks. Thank you. I don't know. Okay. I gotta get you some textbooks. All right. Here we go.